Welcome to Module 2, Lesson 6. We are going over polynomial functions and inequalities. To prepare for this lesson, it will be a good idea for you to review and know quadratic inequalities, because when we go to polynomial inequalities, it's just a little bit more complicated, right? So if we get this one that's pretty simple, then we go up a little bit harder, it's not too much worse. Here are our learning objectives. We need to determine whether a function is a polynomial, and if it is, identify its degree. We need to identify end behavior and identify zeros of a polynomial function and their multiplicity, and then solve polynomial inequalities. Guessing you've already used this QR code, but as a reminder, you can pause and rewind as often as you need, so this lecture is at your pace. And then this lesson homework is due on. Check your course schedule or calendar to see when this is due. Let's go ahead and go to the next page, and we are going to do this page in this lecture video. So we start with the definition of a polynomial function, and it says a polynomial function one variable is in this form right here, where, and it tells you some information about this. So where each n minus 1 is greater than 0 and an integer. So what are they talking about? That n right there is that exponent. So this is x to the n, this is x to the n minus 1. And so they're saying all of these exponents need to be greater than 0 and an integer. So why is this not a polynomial? Well, this one here is x to the negative 4. This needs to be greater than 0. This is less than 0, so that makes it not a polynomial. Also, it needs to be an integer, which means it's a whole number. This one is to the 1/2 power. So all of these have exponents here that are positive whole numbers. And notice how it says n minus 1 all the way down to x and no x. What that means is those exponents need to be in descending order. So you always want to start with the highest exponent. We have x to the 5th, then it goes down to x to the 4th, x cubed, x squared, x, no x. Same thing here. It goes x to the 8th, but then I have no x to the 7th, 6th, 5th, or 4th. Then we have x cubed and x squared. It's okay that they miss some x's, but you still want all of these exponents to be going in descending order. So if I had this as x squared and then x cubed, and these were backwards, that wouldn't be in proper form. Okay, the definition goes on to say that your a sub n minus 1 to a1 are all your coefficients. So my coefficients here are -6, 4, -1, 17, -5. And then here it's 1/4, -1, and 12. So kind of pay attention to one thing here. Notice that this coefficient here is a -6. It's okay for that coefficient to be negative. It just can't be negative in the exponent position. Notice that my coefficient here is 1/4. That's okay too. I just can't have the exponent being a fraction. And then lastly, it says a sub 0. This one over here is your constant. So I have a constant right here of 1 because it has no variable with it. Now, those exponents we really want to pay attention to, because the degree of the polynomial is the highest power n. So here, my n would be 5. Here, my n would be 8. So if those are in descending order, which they should be, it's whatever that first exponent is, but always kind of check. You want it to be the highest one. Now, n tells me two different things. First, n tells me the maximum number of zeros or x-intercepts. So these mean the exact same thing. So you need to be familiar that when they ask for zeros, that they're talking about x-intercepts or vice versa, right? So if n is the maximum number of zeros, that means this one here has a degree of 5. So it means it has a maximum of 5 different zeros or 5 different x-intercepts, or even 5 different solutions. If this one is x to the 8th, my n is 8, so it means I have a max of 8 zeros or 8 intercepts. If you remember when we solved quadratic equations, most of those were x squared, so we got 2 answers. There was one question that we had an x cubed. We got 3 answers, and those 2 answers, or that one time we got 3 answers, those were represented by our x-intercepts. Then if you take whatever your n is and you subtract 1 from it, that will tell you your maximum number of turning points. So if I have n to the 5th, that means a degree of 5. I have at most 5 zeros or x-intercepts, and it will turn a maximum of 4 different times. If you have x to the 8th, that means our n is 8. We have at most 8 zeros or x-intercepts, and we will have 7 different turning points. Now, the degree of the polynomial is going to tell me a lot, obviously, these things here. It's also going to come into a big play when we go over in behavior, which is going to be next video. Along with in behavior, we also need to look for the leading coefficient of a polynomial. And it says the leading coefficient of a polynomial is the coefficient of the highest power term, a sub n. So a sub n is always with that x to the n power. It should be that leading coefficient, or so that leading number, right? So this is my leading coefficient is -6. Here, my leading coefficient would be 1/4. Okay, so let's answer the questions that we kind of just talked about and described here. Example 1. If we have f of x equals -2x to the 6th minus 3x cubed plus x to the, or 5x minus 7. Notice it's going x to the 6, x cubed, x constant. So it's in descending order. First, what is the degree? So again, the degree is your highest power. So my degree here is 6. That is my n. So what's the maximum number of zeros? My zeros go with whatever n equals. So if n is 6, my maximum number of zeros is 6. What's the maximum number of turning points? My maximum number of turning points is my n minus 1. So if n is 6, 6 minus 1 gives me 5. And then what is my leading coefficient? My leading coefficient is whatever's in front of my highest degree. So this would be right here. This is my LC. So my leading coefficient here would be -2.